Hello and welcome back. So on the workbench, you can see I've got the battery charger taken apart, and it's been worked on before. If you can see in here, somebody's replaced the fuse, bridge rectifier, and probably the IGBTs that are down here, just based on all these screws have been taken out, so they're not, don't have a little torque mark on them lining up anymore. Probably had something to do with water getting in it, because this screw is really rusted. And these guys are really rusted. So probably shorted it out or did something, popped a few things. But somebody's replaced it. We know that all works because it powers up and runs for a little bit. Other than that, I don't see anything else wrong with it. Like the screws over here look fine. So it's like water was just, none of the other screws look bad. It just looks like this section was the one that got wet. So yeah, it doesn't look horribly bad. And like I said, we know it works for a little bit, so we got to figure out what's causing the shutdown. So my guess is one of the sensors, could also be one of the power supplies. So we're gonna have to check all of that. So yeah, I don't have the schematic for this battery charger. Actually, I don't have a schematic for any of the battery chargers, but we can kind of figure it out. I mean, these are all resonant power converters. They're switch mode supplies, and this one happens to be a zero crossing. They're typically all zero crossing just because it lets you get away with smaller MOSFETs, lowers your losses, or in this case IGBTs, because of the higher voltage. I'm pretty sure it'd be IGBTs on this end, on the front end here. I can go over like the basics. Yeah, we can do that. So you've got AC power. It goes around, comes in here. This is going to be you can kind of see these two right here. So underneath here, it's potted. Like, I don't know, you can kind of see the yellow potting compound. It's the same stuff they used over here. Solid. So if anything is bad in there or there, very difficult to replace. But inside, underneath here is going to be a common mode choke, because you can see how it goes across there. What else do we have in here? There's ground coming in through here. So we know this is all filtering. We've got a couple wires coming off. They're probably sensing. There's probably, based on the pins here, there's probably a relay in here that does a precharge, and there's probably a precharge resistor. So when you first plug it in, it doesn't spark. It will turn on a relay to precharge and then turn off the relay to remove it out of the circuit. So that's probably going on inside here. This would just be the main input filter. And then after it gets in here, it comes out these two wires here, AC. These would normally go through this hole that's down in there to this board is underneath here on the inside, but I've moved it so we can power it up externally here. So AC comes in here. We got an input protection fuse. We get bridge rectified. Bulk DC gets put over here. We've got, this is a current sensor, resistor, current shunt. And interestingly, we've got a MOV on the DC side. Not quite sure. Normally that's on the AC side, but there might be some in here, or a spark gap for lightning protection on the front end. But it's kind of odd to have a MOV on the output there, like that on the DC side. Then we've got, this is the main switch mode supply that's generating probably, I don't know, I haven't actually powered this up to measure it, but it's going to be probably in the 12 to 15 volt range, something like that, which will be the main supply for everything. Powers everything. Down underneath here, we've got two IGBTs. You can kind of see the 3 pins there. They're bent underneath, so they'd be under here. They'd be like really big ones, like, TO, what, 247, the big MOSFETs with the offset pin, or IGBTs, they're probably IGBTs. We've got some filtering caps, and then this little current sensor here is a little Hall effect one. Like I said, this is a zero crossing converter, so we're gonna wait for they're gonna pump a sine wave into it. It's probably going through these two caps here in series, goes in, and then it switches. And when the current reaches 0, then they toggle it they turn this guy on, current will go up, and then when it comes back to 0, they'll turn the next guy on. That'll complete the next cycle, and it just goes back and forth and pumps power into. This is a big planar transformer, so if you look, it's actually made out of a PCB, and there's probably, it's pretty thick. It's probably a centimeter thick, a little over half an inch, and yeah, it's just got this big ferrite chunk that's in it, and it's bolted together. But yeah, that's just a big transformer. And then the output of this, we're going to, down in here you can see, it's probably easier on this side, see the 2 pins, there'll be a diode, another diode, and then there's another one there. So that's your full bridge rectifier for the output of the transformer. Goes to these capacitors here. These are very small, so these are just filtering caps. And then this is a giant inductor. It's not an actually transformer. You can see on the side here, it's actually just an 11 microhenry inductor. And then, so that's doing a high frequency filtering. And then it goes into this bulk cap. Although, the output, yeah, so this, yeah, I guess that would put energy onto the bulk cap. And then if we look here, we've got this relay and this resistor, which does appear to be cracked, but I checked it, it's still good. It's just a wire wound resistor and the casing starting to crack. This would be the precharge for the battery. So when they hook that up, this relay looks like it connects the output to the battery. We'll cover that in a section. This goes out to the battery to charge it, and it looks like they pre-charge the battery into this capacitor as well with this relay and that resistor. But then they have the ability to actually turn the output on and off as well. And probably do that to keep, so they don't burn up energy when it's off by measuring the pack voltage all the time. And if we look down in here, see how there's 4 terminals in a row? This is the current sensor. See how they got really big trace coming in here, really big trace, and then the 2 little traces coming out of the middle here? That's a Kelvin connection to a current sense resistor. So that's probably a big pack underneath, probably lays that way because the relay pins would be in the way. So it's under there like that. And then these diodes are probably underneath those capacitors as well. But that's the power stage. Then it comes out over here. We have an output filter, choke, and then some filtering with some capacitors that are in there. Also potted, impossible to fix. Then we go in through here, and we've got our main output fuse, and then it goes out this to the to here to plug into the battery. Then on here, in the middle of here, we've got all of our I/O. Goes out, there's some LEDs that goes out to the little control box. Those all go out through this connector. I believe this one's probably, like I said, it's either a relay, and then this is probably an input voltage sense for the AC lines. And then we've got, what else do we have? I'm going to guess that all of these resistors in series, and then the group back here in series, these guys are all, see how they're all connected in series like that. That's your high voltage measurement, and then that's coming down to one of these pins on this connector, which is unplugged right now. That goes over to here, and that's how it's measuring the output voltage to the battery pack. So we could have a problem in that section. Could have a problem over here with what's reading the current sense here. I did check it; it does read okay. So that's that, and then let me grab my chair so I can sit down. So we got this other board here. This is the main controller board, and it runs along the side here. So if I've got it unplugged right now, so we can pop it out here. Actually, you know what? I'll just put it up here. So this is what's actually the brains of the operation. So, and this could be also a problem. We've got these guys have gotten really hot. You can kind of see that there's some cracks there. So we got those guys, and then if we go on the back side, these guys have also been getting fairly warm. You can see how the board's discolored. So we could have a problem with those as well, such that, you know, they work perfectly fine, then it warms up and then one of those traces breaks. So I'll probably resolder all of them, kind of like if you see here how they did this, where they've just kind of filled the gaps in with solder. I'll do the same thing to beef them up, because that'll give them some more heat dissipation. I checked them, they're all good. And like I said, we know it works. It just doesn't work it doesn't continuously work. So on this board, you can see that we've got all these connectors that go off to the different ones here. And they're pretty isolated, so we know this section goes to this connector. We've got, you can see we got some voltage sense lines coming in and everything. And actually, that's probably, yeah, voltage sense lines are coming in. And probably also powers the other supply, but here, I'll show that in a second here. But if you notice, there's no MOSFET over here to switch this guy, the main supply, and that's because it is located right here on the board. So you can kind of see it goes over to these pins to switch that. And you notice, like, all these resistors in series, anytime you see that, that's a high voltage measurement circuit. So that's a voltage divider, and that's probably measuring, so it's going to be after the bridge, so that's probably measuring the bridge rectified DC that's coming in. And then we also have, so this also runs off of the high voltage, and they probably did it that way, or the bridge rectified DC. They probably did it that way so they could test this board individually without having to have an intermediate supplies. But you can tell that because this is a 400 volt input capacitor, and this is another supply. So this is an inductor transformer that's switched by this guy, and this forms a little power converter with two outputs. So it's probably like a plus and minus supply or something like that. Again, I haven't powered this up, so I don't actually know. And then that goes off to supply power and everything. You can see it runs over here. We've got a linear regulator. This is probably generating the main 5 volt supply, which runs the micro and everything. You can see their isolation gap on this side. So this is the high voltage. These are going to be the MOSFET drivers, or these are a bunch of MOSFETs, and they plug it. They go to this connector, which I feel like is the ones going there, and they run off underneath to power the IGBTs that are underneath the board there to turn on the transformer or to switch to primary. And so all of this section here is a voltage sense, and it's going to take in this current sensor back as well, and then that whole section is going to do the switching zero power converter, or zero crossing power converter. Yeah, so this whole section is the zero crossing power converter, and then it's all isolated. You can see that we've got a couple optocouplers here, and this is a what are those called? It's a photo. Shoot, I don't remember what they're called. Essentially, we have LEDs. We got one LED and essentially two photodiodes, and then you can close the loop on there. You shine light on the one onto both of them, and then you close the loop and you can do an isolated analog measurement. So that's probably reading one of the voltages coming in, again, through all these high voltage resistor packs here. Yeah. And then we've got, so if you follow the isolation, this whole board's isolated, and then it goes through this way. And so the middle part here comes over, and then that gets all of this is just the I/O and various filtering for the main micro. And then it looks like we've got probably a PROM, maybe an EEPROM, because it's got, or yeah, it's probably a PROM, although no, I don't feel a window on it. I would guess that it's actually just an EEPROM, which has the either, yeah, I'm going to go with, that's probably the code. And then this is an address decoder, some kind, because the yellow line's running over to it. And it's probably an address and data decoder. But the micro on here is a, if it'll focus, whatever, a TN80, I mean, it's an Intel, whatever a TN80 C196K C20 is. It's just 8280. I don't know, but probably doesn't have any internal, or just has enough to do bootload, or they needed some extra because the code didn't fit in it, so they grabbed that. Runs at 16 megahertz, and probably has, I wouldn't be surprised if one of these is like a little serial EEPROM to store like information, although I don't think this has a serial port on it or anything, so I don't know if it keeps statistics of how long it's run and how many amp hours it's used and stuff like the other ones. But yeah, everything else just op amps to do the got one little bodge wire there. But that's it. I think that's a decent overview of how the system works. Granted, I could be wrong, but usually they're pretty common. They're all, you know, the same topology. Once you get into the higher power and 3 kilowatt range, it starts, you know, kind of merging towards the zero crossing converters, power converters. But yeah, so I'm gonna try to tilt this up and get this to plug into there. Get this guy plugged in. I'm gonna measure, see what the sensors are doing, check the power supplies, and check the output. Because it could be that it runs for a little bit because, you know, we're running off the capacitor. You know, it can generate just enough power, the capacitors, get it up and running, and once we start, you know, we start sagging the caps down, and then eventually it drops out. So it could be something simple like that, in which case we've just got, you know, we just can't keep up. It's got a bad capacitor. It could be, you know, enough noise that it's kicking out. You know, it could be a lot of things. So just got to hook it up and do some more troubleshooting. Anyways, thanks for watching. Bye.